Hi, I'm Lim. Today I want to present for my final year project 1 with title Characterizing the Welding Response Signal to Understand the Welding Behavior in Solid State Welding. First, introduction. Friction state welding is a type of solid state welding that use frictional heat generated by a rotating tool to join material. It can be divided into two types: conventional friction state welding and also bobbin friction state welding. The figure below show the difference between these two types of welding. We can see for the conventional friction state welding only has one shoulder, but for the bobbin friction state welding has double shoulder. In our case, we are focusing on the bobbin friction state welding. Problem statement. The quality of welding is a critical role in most industry. The quality of welding may affect by the type of welding signal. Every welding signal is sensitivity to any change in welding process. This paper is to analyze and characterize the welding signal effect to the quality of welding. Next, objective. The objective is to characterize the welding signal measure during welding by using mathematical and graphical approach, and also propose the relationship between welding signal and weld formation to characterizing the weld response. This is the literature review that I'm searched. For the first figure, we can see the micromorphology of weld surface at different rotational speed. This shows that the higher the welding speed, the lower the spacing of ripple. For the second diagram, this is the graph to show the relationship between two rotational speed with temperature. The result is the rotational speed is perpendicular to the peak temperature. The third diagram, this diagram is show the effect of rotational speed on workpiece. We will see the higher the rotational speed, the higher the force applied on the workpiece. What we can conclude is every parameter has a relationship with each other. Methodology. This methodology only for characterize the welding signal. Phase 1, creating data. Literature review on previous research from previous experiment. This is the data that I'm get from the previous researcher. Data 1, current versus time graph. Data 2, temperature versus time graph. Data 3, vibration versus time graph. What we can see is in this graph get many noise that make us too difficult to characterize the signal. So what I'm going to do is how to simplify the noise, to decrease the noise in the graph, so we are easy to detect the signal. For the phase 2, design of experiment, DOE. By using Minitab software. Minitab is a package of software to solve problem and analyze the data. Why we said it's the package of software? Because in Minitab it get many function. These are the method in Minitab software. First, full factorized software. Second, Taguchi software. Third, response surface software. First, the full factorized method is used as screening design to reduce the number of input by identify the process condition that affect quality of the product. The second, Taguchi method, to robust parameter design with allow to analyze many factors with few runs. Focus on minimizing variation and or sensitivity to noise. The third, response surface method. It can apply after we have identify a vital field controllable factor to find the factor setting that optimize the response. Okay, this is the step of Minitab. First, create design experimental metric. Second, input experimental factor. Third, key in experimental data. Fourth, define custom Tagogi design. And the fifth, analyze and setting the objective. And the sixth, create optimization level and plot the graph. Okay, expected result. This is the result what I expect to get. Okay, this is the graph that look like what I'm expect to get. Okay, in this graph, the noise are reduced and then easier to read and detect the signal in every stage. So we can reduce the defect in welding. Okay, thank you.